Hey, do you ever miss the good old days?
What do you mean?
Do you miss the days where we didn't have to worry about computers and all this technology?
Dude, I am way too young to remember those days.
Aren't you tired of all these kids playing the Fortnite and they don't even realize the good old games we used to play?
Once again, I am way too young to know what you're even talking about, man.
Dude, I'm talking about family games. You know, the type of games you pull out of the closet and play on family game night.
Oh, I think I've heard of something like that before, but what types of games were there?
You had games like chess and Monopoly, but you know, there was one game that really stood out.
What game was that?
Obviously, Connect 4.
Oh, yeah, I think I heard of that one before.
Yeah, let's take this old classic and bring it to these newer generations.
How are we going to do that?
All we have to do is make it a game on a platform the younger generations can use.
Oh, like a computer.
Exactly.
All the kids are playing games on computers now. It's the future of gaming, really.
In that case, the computer is the perfect place for the game.
Yeah, we can bring together the older generation who likes the game to the newer generation who can't turn off their computer.
Do you think the older generations know how to use it?
Oh, sure, we can easily program the game to make it easy for older audiences to play.
Sounds like a win-win for everyone.
Now we just need to let the world know about our game.
And that's exactly what we just did.
Hi, I'm Parker Arnold, and I was the lead developer on this project.
Hi, I'm Evan Pulling, and I was the director on this project.
My name is Devlin Murphy, and I was the head scribe for the project.
Hi, my name is Hrabusa, and I was the developer and producer on this project. We created a digital version of the classic game Connect 4 with the computer software MATLAB. We created a version of Connect 4 because it's a fun, simple game that anyone can play. We used MATLAB's easy graphics and matrix manipulation in order to place each chip and create an unpredictable AI.
We try to make our code as easy to read and efficient to run as possible. To begin, the board is printed to the screen, and then a fake board only used in our algorithms is created of all zeros. Then the rules are printed, and then is game finished is created. This is a very important variable in our code that runs the while loop that keeps giving people a new turn. As soon as it is not equal to 0, the game will end, and we'll talk about that later. And then a coin toss is simulated by generating a random number between 0 and 1, and then routing that number down to 0 or up to 1, and then checking that against the player's input. Turn is then created right here, which determines whose turn it is. This is done by modding it by 2, which will either give us 0 or 1. If it gives us 0, it's the player's turn. If it gives us 1, it's the computer's turn. So for the player's turn, they are asked for a number between 1 and 7, known as the column number. So just like choosing which column you're going to drop your chip into when you play the game in real life, if they give us a column that doesn't exist, like -1 or 8, they lose their turn and it goes into the computers. Otherwise, the row number for that column is found using determine row number, which takes in the board that we made and the column number the player gave us and goes through from bottom to top of that column and gives us the first row that's free. So it's basically a simulation of gravity. Next, the board remembers that the player placed their chip there, and then it is printed to the screen. At the end of the while loop, is winner is ran right here to determine if anyone has won the game. This is checks for 4 in a row horizontally, vertically, and then it also checks diagonally, but diagonal was a lot harder to code. So we had to make 4 different nested for loops for this. It checks from different corners of the board from where a win could start. Going back up to the computer's turn, the computer generates a random move on the board and then returns the column number. So it checks for the first free spot it can find using random number generation. And then determine row number is run to find the row number for the column that is returned. So that move is then registered by both boards, and then it is also printed to the screen, just like for the player. In the case of a tie, we have this if statement that checks for if there are no more free spaces on the board. If the board finds a free space, so one that's equal to 0, tie will be equal to 0, and then it will return. Otherwise, there are no more free spaces, and it is a tie. So after the game finishes and someone wins or it's a tie, the board is printed to the console one last time, and then it prints who won based on is game finished value. And that is our code. This is our code in action. We begin by hitting the run button at the top of the screen, and this figure is generated. Then we get this little arrow on the top right, which docks it, so we don't have to see messy code in the background. We can just type our answers and watch the board change as we play. The rules are generated, and then we get to do the coin toss. So we're going to say 1. We got it right, so we have to go first. Let's choose the 5th column. And then the computer instantly does their move. We're black, the computer is red. Let's do 6. Let's do 4. Obviously, the computer is not very smart, so it doesn't try to counteract you as much. If we give it a column that doesn't exist, like -1, it tells us we lost our turn. The computer goes, and then if we end up winning, hey, look at that, we won. And obviously, we were able to win diagonally, but also vertically and horizontally. And that is our code.